Alright, I want to talk a little bit about absolute extrema here. So, before we get into any examples, there is a theorem called the extreme value theorem that says if a function is continuous on a closed interval from a to b, then there must be an absolute maximum value and an absolute minimum value on that function somewhere on that interval. Okay? And what that means is that there is some value, meaning when I say value I'm referring to y value, in between a and b, that is larger than all the rest of the values. Okay? So in this case, I'm looking at, would be looking at this point right here on this graph where, this y value is larger than anywhere else on that graph, okay, in between a and b. And so this would be what we call the absolute maximum value. Okay? And so the absolute maximum value, what that's referring to is the y value at that point. Okay? And the absolute minimum value in this case would occur right here because this is the lowest y value for this function anywhere in between a and b. So this would be the absolute minimum value. And again, this, sometimes the confusion is some people would say, oh, what is the absolute minimum? Someone might say, oh, x equals a is the absolute minimum. Well, that is where the absolute minimum occurs, but the actual absolute minimum value is the y value at that point. So usually on an AP test they ask, what is the x value of the absolute maximum? So you would say, okay, well, whatever that x value happens to be, but just want to keep that in mind. Okay? So, and again, one example that I like to show here is something like this. If you have a graph that looks like this, is just a horizontal line from a to b, that's always a question that comes up. Well, there's an example of one that doesn't hold true. Well, it does actually. It's just the fact that, the absolute maximum value and absolute minimum value are actually the same number in that case. So, whatever this y value happens to be, let's say that's the line y equals 7 or something, okay? Then 7 would be the absolute maximum value and 7 would be the absolute minimum value, okay? Kind of weird. But what I really want to focus on for just a second here before we get to an example is where absolute extrema can occur, okay? So you'll see on our example right here, one of the absolute extrema, in this case happening the minimum, occurred at one of the endpoints, okay? And the other absolute extrema occurred at a relative maximum, okay? Which a relative maximum would be a hilltop, where a relative minimum would be kind of like a valley in a graph, okay? And we'll talk more about relative minimums and maximums in later videos. So one of the keys though is, okay, well, the endpoints are pretty clearly to define. So an absolute extrema could occur at an endpoint, okay? So that's something we've got to keep in mind. Now this absolute extrema right here occurred, like I said, at a relative maximum at a hilltop, and notice what the slope was at that hilltop. The slope, which I'll refer to as m, is 0, okay? So that's, when you think of possible places where absolute extrema can occur, it can either occur at the endpoints or where the slope is 0. Or there is one other possibility, okay, and that would be where the slope is undefined. For example, let's say I had a graph that looked like this. Okay, so say it started up here and I had something that looked like this. Okay, so in this graph right here, my absolute maximum would be right here, okay, at the initial endpoint right there, and my absolute minimum would occur at that point right there, which you can see right here, this graph is not differentiable at that value right there. Okay, so that's where the absolute minimum occurs, and the graph's not differentiable there. All right, since you got this pointy V thing, the slopes don't agree as they come in from both sides. Okay, so again, it can either occur at an endpoint or where the slope is 0. That doesn't mean that it's always going to occur at one of the endpoints. Like you could draw a graph like this, where let's say at x equals a, and here it finishes at b. So at x equals a, it starts right here, it goes down like this, comes back up, and then finishes out right here. You can see in this case, neither one of the endpoints happen to be absolute extrema. The absolute minimum occurred right here, the absolute maximum occurred right here. But in both of those cases, take a look. Slope is 0, slope is 0. Okay? So it occurred where the slope happened to be 0. You could also have it where it occurs at, just the endpoints. Okay? So I could have something like this even. So it starts at A, goes to B, starts here, goes down to here. Well, there's the absolute maximum value, there's the absolute minimum value, but there's no way to draw it if the function is continuous, where the absolute maximum does not occur either at an endpoint or where the slope is 0 or undefined. So, with that in mind, let's try and look at an example of how we find absolute extrema.